Hello everyone. Now let us begin with the operating system. Is my voice audible to everyone? Check it once. Now let us begin with the operating system. Okay. What is operating system? Is a system software that acts as an interface between user and computer hardware. It acts as an interface between user and computer hardware. That is called operating system. It manages hardware, software, resource, and provides common service for computer programming. Introduction to operating system. An OS is system software that manage computer hardware and software resource, I told you before, and also attached as an interface between user and hardware. Examples are Windows, Linux, Mac OS, Android. These are the examples for operating system. And functions of this are it manage the hardware resource like CPU, memory, input and output. This main function is to manage hardware resource like CPU, memory, input and output. And it provides user interface for CLI or GUI. I told you the full form for GUI in the previous session. So, what is GUI? What is the full form of GUI? Graphical user interface. I told you when explaining the basics of computer. GUI means graphical user interface. And what does it stand? Then what is CLI? Full form? Command line interface. CLI stand for command line interface. Got it? Okay. This mainly operating system mainly it executes and provides service for application software. It mainly executes and provides service for application software. Then functions of operating system. Process management, memory management, file system management, device management, security and access control. So let us see one by one. Process management means it creating is also a process, scheduling is also a process. Create, schedule, and terminating. Terminate. Process management means creating, scheduling, and terminating. These are called as process management. Memory management means allocation and deallocation of memory space. Allocation and deallocation. Sorry. Deallocation. File system management controls how data is stored or retrieved. File system management is of controls how data is stored or retrieved. Control how data is stored or retrieved. Then device management means manages input and output device through device driver. Manage both input and output devices through device driver. Then security and control. Access control means protect data and system resource. Security and access means protect data and system resource. Protection. Security means protection of data and system resource. Protection of data and resource. I'll repeat it again. Process management is nothing but creating, scheduling, and terminating. This is called as process management. Memory management means allocation of memory and deallocation of memory space. That is called memory management. File system management means control how the data is stored, control how the data is stored or retrieved. Device management means manages input and output device through device driver. Input and output. Security and access control protection. Protects data and system resource. Next, types of operating systems. We have batch OS, time sharing OS, distributed OS, real time OS, network OS, mobile OS. We'll see one by one. What is batch OS? Batch operating system means no interaction with the user. One second. No interaction with user. No interaction with user. Then its main job is with the similar needs or grouped. It works with similar needs or grouped. Example for this, the example is earlier IBM system. Earlier IBM system. Not present IBM, it was the earlier IBM system is the example for batch OS. Time sharing OS. Here no interaction in the first one, but here enable multiple user to use the system simultaneously. See, this is different. Batch OS, no interaction with the user, but time sharing OS, it enables multiple users. Multiple enables multiple users to use the system simultaneously. Sorry. Simultaneously. And here time slice is allocated per user in quantum allocated per user. Time slice is allocated for per user. Okay, time is shared. Distributed OS. Distributed OS means manages a group of distinct computer. Manages a group of distinct computer and make them appear as a single system. It's manage a group of distinct computer and make them appear single system. Real time OS. Real time OS. For distinct OS, I'll give you some example. Locus. Locus is the example for this. For next one is real time OS. Real time OS means respond immediately to the input. Real time OS means it's response immediately to input. Immediate response for the given input. Then where it is used, real time OS, it is used in embedded systems like pacemaker, flight control, used in embedded system like pacemaker. Then another example is flight control. Then network OS. Network OS means provide service over a network. For example, Windows Server. Windows Server. Windows Server. Then what is mobile OS? Designed for mobile device. For example, Android and iOS. Mobile OS is designed for mobile device. Example, Android and iOS. These are two operating systems we know in mobile OS. I'll repeat it again. Batch OS, no interaction with the user, but time sharing OS there is a multiple user interface with the simultaneously. Distributed OS means manage a group of distinct computer and make them appear as a single system. Then real-time OS means respond immediately to the input. I have given the example in embedded system, that is pacemaker and flight control. Then network OS. Provide service over network is called as network OS. Example, Windows Server. Mobile OS, which is designed for mobile device. Example, Android and iOS. Next. Process management. A process, under this process management, let us learn about first what is process and what is thread. Okay, process is a program. A program in execution is called as process. Program in execution is called as process. Program in execution is called as process. Okay, then thread means a lightweight process. A lightweight process is called as thread. And this one will share the codes. Thread will share the codes and memory with other threads. Please listen carefully. Thread will share codes. Thread will share codes and memory with other threads. Thread, THREAD. And this is faster. We know that what is process means. Process, a program in execution is called as process. Then this process has its own address. This process has its own address. Code, data, and stack. And these states are process status, new, ready, running, waiting, terminated. These are the states of process. And next is context switching that comes under this thread. Faster context switching. This is faster. Thread is a faster context switcher. And this process management also schedule algorithm. Now we'll study completely about this process scheduling algorithm. I'll repeat it again. What is process and what is thread? A process is a program in execution. A program in execution is called as process. And thread is a lightweight process which share code and memory with other threads. A thread is a lightweight process which shares code memory with other threads. Then this is a faster context switching. And process states are new, ready, running, waiting, and thread terminating. And this process has its own address code, address space, code, data, and stack. This is all about the process. Now we'll see what is process scheduling algorithm. Yeah, this is process scheduling algorithm. First come, first serve. FCFS means first come, first serve. SJS means shorted job first. Round robin, RR. Priority scheduling. And another one is that is multi-level queue scheduling. Fifth one is multi-level queue scheduling. Got it? Okay. This is the algorithm of process scheduling algorithm. First is first come first serve, then shortest job first, round robin, priority scheduling, multi-level queue scheduling. Now we'll see about memory management. Memory management means allocation of space, memory space to process. And concept paging and segmentation. And third one is virtual memory. We'll see one by one. Allocation of memory space to process. Memory management, continuous memory allocation. Continuous memory allocation. Its work is to give a continuous memory allocation. What is page? It divides memory into fixed size, like pages or frames. It paging means divides divides memory. It divides memory into fixed size. Next. size. In pages or frames. In pages and frames. Logical address is page number plus offset, and its logical address will be logical address is page number plus offset. Then let us see what is segmentation. Segmentation is memory divided based on the logical division. It is memory divided based on the logical division. That is code, stack, etc. I'll repeat it again. Paging means it divides the memory in a fixed size. Divides the memory in the fixed size, pages or pages and frames. It divides the memory in a fixed size. It's called as pages. Paging. It is called paging. So segmentation means it divides the memory based on the logical division. What are logical divisions? Code, stack. These are the logical division. Based on that, they are going to divide the memory. Okay. And logical address of paging will be page plus offset. Logical address will be page number plus offset. Logical address of this paging will be page number plus offset. Then, what is virtual memory? Virtual memory means virtual memory. In this, it uses disk as an extended RAM. What is RAM? Random access memory. So this virtual memory uses disk as extended RAM. And also uses demand paging and page replacement algorithm, like it also demand paging and page replacement algorithm, like it demands for FIFO. What is FIFO? First in, first out. LRU means what is LRU? Least recently used. LRU means least recently used. This is all about memory management. Allocation of memory space to process is called as memory management. In this, we'll see about a paging and segmentation. Paging means it divides the memory in a fixed size, like pages and frames. Here it has a own logical address, like page number plus offset. In segmentation, there it is divided in the memory is divided in logical division. The segmentation, the memory is divided based on the logical division. Code stack or etc. Based on this, they are going to divide in segmentation. Then virtual memory. Virtual memory means it uses disk as an extended RAM. So it demand paging and page and replacement algorithm like FIFO and LRU. FIFO means first in first out. LRU means least recently used. File management. File management, organization, storage, retrieval, naming, sharing, and protection of files. That is called as file management. It is nothing but a method to store and organize data is called as file system or file management. Storage of store or organize of data. Store and organize data is called as file management. And directory structure are single level, two level, three structured or hierarchical. This is also tree structure means it is a hierarchical. It is also called as hierarchical. Mainly the file operation is create. The file operation is create, open, read, write, close, delete. These are the file operation. The file attributes, see, organization, storage, retrieval, naming, sharing, and protection of file is called as file management. And in this, directory structure are single level, two level, and hierarchical, or it is also called as tree structure. Then file is nothing but storage or organization of data is called as file system. Then file operation. File operation. Create, open, read, write, close, delete. These are the file operation. Okay, before going to deadlock, we'll see what is IO I/O management. Okay. What is IO management means input and output management. Manages communication between input and output device and system. It manages the communication between input and output device and system. That is called IO management. Then, and it uses device drivers. It uses device drivers. It mainly manages communication between input and output device and system. Then uses device driver. To manage this, the uses device driver. Then input and output techniques are programmed input output, programmed input output, then interrupt driven input output, and direct memory access, DMA. DMA. Direct memory access. DMA means direct memory access. These are the three techniques are used in IO management, input and output management. Now we'll move to the next topic, that is deadlock. Deadlock conditions are mutual exclusion, old and wait, no preemption, circular wait. First, let us see what is this deadlock. This is a state in a multi-programming environment where two or more processes are unable to proceed because each is waiting for the other to release a resource. Listen again. Here, I'll repeat it again. A deadlock is a state in a multiple programming environment where two or more, if there are two or more processes are unable to proceed because each is, imagine there are tasks continuously. Okay. The task is completed by one. So here, where two or more processes are unable to proceed because each is waiting. See, each is waiting for other to release a resource. So it has to get a resource from other one. So then only it is possible to process. So that waiting is called as a deadlock. Each process waiting for resource held by the another process, forming a cycle of dependency. You can imagine two people as to pass. Both are in opposite direction. there is there is a small space where only one person can move. So here this person is waiting for this person to move first, and here this person is waiting for that person to move first. This is a real-time example. Each one is waiting for other person to move. This is called as deadlock. Then we'll see what is mutual exclusion. This is called as at least one resource must be held in a non-shareable mode. Write it out. At least one resource must be held in a non-shareable mode. Non-shareable mode. Hold and write. A process is holding at least one resource and waiting to acquire additional resource. This is in non-shareable mode. Mutual exclusion means this is like it has at least one resource and it is waiting to acquire additional resource. It has already have at least it has already have one resource, but still it is waiting to have a additional resource, waiting to acquire additional resource. No preemption means resource cannot be forcibly taken away from a process. No preemption means resource cannot be taken forcibly away from the process. They must be released voluntarily. Resource should be released voluntarily. It cannot be taken forcefully from the process. Circular wait means a set of processes are waiting for each other in a circular chain. Waiting in a circular chain. I'll repeat it again. The set of processes are waiting for each other in a circular chain. This is called circular wait. Then we'll see what is deadlock prevention. And deadlock avoidance and recovery techniques. First, we'll see prevention. In this prevention, there are four techniques. One is we have seen already, that is mutual exclusion. Not always preventable. Some resources are inherently non-shareable. This in under prevention, there are four types of technique. That is, first one is mutual exclusion. That is here. I already explained what is mutual exclusion. Hold and wait requires all resource be requested at once. Hold and wait, that also comes under prevention one. Then no preemption, allow resource preemption means it has to wait. It cannot be taken forcibly. That also come under the prevention technique. Then circular wait. This also come under the prevention technique. Under prevention, there are four techniques. First one is mutual exclusion, hold and wait, and then no preemption, circular wait. These are the four techniques comes under prevention, deadlock prevention techniques. Next, we'll see about deadlock avoidance. This avoidance is basically this is a dynamically examining resource allocation and ensuring the system is in safe state. It always ensures that system is in safe state. It examine the resource allocation and ensure always the system is in safe state. That safe state means there exists at least one safe sequence of process execution. So here this is mainly it focus on the system whether it is in safe state or what. It mainly focus on to check the system is in safe state and resource allocate and dynamically examine the resource allocation. That is nothing but deadlock avoidance. It check the allocating a resource keeps the system in safe state or what. It always check. That is nothing but avoidance. Next, recovery. Recovery technique is of two types. One is process termination and another one is resource preemption. This is of two types, process termination and resource preemption. Okay, we'll see what is process termination. Process termination means about all deadlock process. It about all the deadlock process. And another one is about one by one until deadlocks ends. One by one. Process termination means abort all deadlock process at once, and second one is abort one by one until all the deadlocks ends. That comes under process termination. Then resource preemption means it takes resource from one process and gives to another. Resource preemption. No, here we have seen what is no preemption. Forcefully, you cannot take any resource from the process, that is called as no preemption. Here, resource preemption means it takes the resource from one process and give to the another. Take resource from one, take the resource from one and give it to the another process. Take the resource from one process and give it to the another process. That is called resource preemption, which comes under recovery techniques. And if it not handled properly, it can cause starvation. It can cause starvation. Huh? The one word statement for this is it is a process waiting indefinitely for resource. It is a process of waiting for the resource. Process of waiting for resource is called as deadlock. We'll see about system calls. System calls in OS. System call means interface between process and OS. It is a interface between process, OS and process. One second. System call means interface between process and OS. Types are process control, file management, device management, information maintenance, communication. Under this, we have 5 types: process control, file management, device management, information maintenance, and then communication. These all comes under the system calls. And we'll see example of OS. Example of OS. What are OS? Window is operating system, right? Window. Window is one of the OS. So it is based on GUL. What is GUL? Graphical User Interface. Windows is based on GUI, and it is also a multi-task. Then Linux. Linux is a open source. It's an open source and it's a multi-user. Unix means stable, widely used in servers. Unix is stable. It is stable, widely used in servers. Mac OS is Apple's GUI OS. Mac OS is a Mac operating system is a Apple's graphical user interface. OS, that is Apple's GUI, graphical user interface OS. Android based on Linux kernel. Android is based on Linux kernel. Based on Linux kernel. Kernel. Sorry. Okay. See, based on this, you're going to get a PGCET MCQ question based on, mainly they focus on operating system, types of operating system. We have seen already types of operating system we have seen. Then function of operating system also we have seen. What are for, okay, let us recall everything what we have learned. Types of operating system we have already seen, that is batch OS. Batch OS, do you remember? No interaction with other users, with the user. Then time sharing OS, then distributed OS, then real-time OS, real-time OS, network OS, then mobile OS. These are the types of operating system we have seen. Next, after that, we have seen about function of OS. So what are function of OS? What are function of OS? Process management, memory management, file system management, then device management, then security and access control management. These are the function of OS. First one I have written types of OS, batch, time sharing, and these are the types of OS. And next I have written the function OS. Process management, memory management, file system management, device management, security and access control. These are the function of OS. Based on this, you're going to get a question. Then scheduling algorithm. Scheduling algorithm we have seen. In that, what you have seen? Scheduling algorithm or process scheduling algorithm. We have seen first come first serve, FCFS, then shortest job next, or shortest job first, that we have seen, and round robin we have seen. Then priority scheduling we have seen, priority. One second. Priority scheduling we have seen. Then multi-level queue scheduling we have seen under process scheduling algorithm. After that, we have seen about memory management. Yeah, we'll get a question on mainly on memory management. What is memory management? We have seen already. Continuous memory allocation is called as memory management. In that, we have seen what is paging. Then we have seen what is segmentation. And then we have seen what is virtual memory. What is paging? It divides the memory into fixed size of pages and frames, and it has a logical address as page number plus offset. That is the logical address of the paging. Then what is the segmentation? Memory divided based on the logical division, like code stack. Based on this, they are going to divide the memory. Then virtual memory. This uses extended RAM. Uses disk as extended RAM. Uses disk as extended RAM and uses, and it also demand paging and page replacement algorithm. And also this virtual memory demand paging and page replacement algorithm like FIFO and LRU. LRU means, FIFO means first in first out. LRU means least recently used. That we studied under this virtual memory. After that, we have seen about deadlock. Yes, we have seen what is deadlock. In deadlock, we have seen mutual exclusion, right? Then hold and wait, hold and wait. Then no preemption, we have seen. No preemption means cannot be forcibly taken resource from the process. Preemption, then circular waiting. We have seen about circular waiting. After that, we have seen, and also under this page, process management, we have seen what is process and thread. We have seen what is process and thread. Thread means it gives the data to another thread, right? Process means which execute the program is called as process. Program execution is called as process. Thread means which gives the data resource to the other thread is called as thread. Okay, now let us see difference between paging and segmentation. This is one of the important topic. For this, the definition is logical, divides logical into fixed size. Divide logical into fixed size in pages. Here in variable size. Here fixed size. Here it is variable size. And this is purpose is used for physical memory management. Physical memory management. And this one is used to reflect logical division of program. Use it to reflect logical division of programming. This is for physical memory management, but this is for reflect logical division of programming. This logical address will be like page number plus offset. And this logical address will be segment number plus offset. And memory wastage in this is may cause internal fragmentation. This cause internal may cause internal fragmentation, but this cause external, that is nothing but wastage of memory, external fragmentation. And this is used in system with virtual memory. This is used with a virtual memory, and this is used in programs with modular design. Modular design, like functions array. This one, the paging, is used in system with virtual memory, but this is used in programs with modular designs like functions and array. And next one is, this one is not visible. This is not visible. OS level implementation. This is not visible, but this one is segments or logical unit visible to. This is not at all visible. Remember that this is not at all visible. This is this logical units, segment logical units visible to programmers. Visible to programmers. Visible to programmers. These are the difference of paging and segmentation. Now, let us solve few questions based on this. Which of the following is not a function of a operating system? Which one is, what is the answer is this? What is the answer for this? Which one is not a function of operating system? We are under operating system. Under operating system, we have seen memory management. Yes. We have seen process management. Yes. And we have seen file management. So in this compiler execution, we have not seen. So this one does not come under function of an operating system. This three, first memory, process, and file management, we have seen in function of operating system, but compile execution is not under the function of operating system. So option C for this. What schedule algorithm is best suited for time sharing system? What is the answer for this? For this, the answer is round robin. Because round robin is for time sharing system. Round robin is for time sharing system where multiple users or process share the CPU. So for this, round robin is the answer. See, in first come first serve, it's a simple but poor response time for long process. It's a poor performance for the long process. And SJF, shortest job first, can lead to long process. It can lead to long process, hard to predict job length. It is hard to predict. And priority scheduling means this can cause low priority tasks. The round robin is a suitable answer for this because it is ideal for time sharing system where multiple users of process share the CPU and it takes less time than compared to other one. And it is best suited for time sharing system. Round robin is best suitable for time sharing system. Like this, they can frame a question on this topic. So this is very simple, which is not a type of OS. We have seen batch OS, we have seen real-time OS, we have seen distributed OS, but we did not see word processor. So this is not the answer for this. And this, which of the following is a deadlock prevention method? Which of the following is a deadlock prevention method? Options are, first one is round robin. Then it is a avoid circular wait. Yes, this we have seen under the deadlock method. Then we have seen paging and so which is the answer? Under prevention method in deadlocking, we have seen only the in this option we have seen only this avoid circular wait. So this is the answer. This mainly deadlock prevention is aimed to ensure that at least one of the necessary condition for the deadlock never occurs. So this one is the one of the method of deadlock, prevention method of deadlock. And we'll see the other options as well. Here, round robin is a CPU scheduling algorithm not related to the deadlock prevention. You can get the answer by doing the elimination method because this round robin we have seen in the scheduling algorithm, right? So this is not related to deadlock prevention. So this is not the right answer. Paging, it comes under the memory management. So this is also not the right answer. Scheduling, this comes under general term. This is general term. This also comes under algorithm scheduling, right? So even this does not comes under the deadlock prevention. And we'll see few more questions related to this. Okay. Ask you a simple question. Virtual memory is what? I'll give you the options also along with this. Part of main memory. And another example is, sorry, another option is part of secondary storage. And third one is illusion of having more memory. Fourth one is none of this. So none of the above. So what is the answer for this? So what is the answer for this? For this, the answer is illusion of having more memory. Because virtual memory is a technique that allows the execution of process that may not be completed in main memory. So virtual memory means illusion of having more memory. It gives the illusion to the users and application that they have access to the large amount of RAM. What is RAM here? Random access memory. Then what is physical available? It gives the illusion to the users and application that they have access to large amount of RAM. They give the illusion to user and application that they have access to large amount of RAM. Got it? That is what virtual memory means. I'll give you one more question. Okay. A system is in a safe state. A system is in a safe state if option no deadlock occurs, Second one, the system can allocate resource to each process in some order. The system is always deadlock free. None of the above. So what is the answer for this? A system is in safe state F. So what is the answer for this? For this, the answer is B. Why? Because in a safe statement, the system can allocate resource in a way that avoids deadlock. When it allocates the resource in a way that avoids deadlock, does not mean no deadlock ever happen. So this is not the answer. The deadlock may happen, but this is C option. Okay. Now let us use the elimination method. No deadlock occurs. No, this is not the right answer. This is also not the proper answer. So this is also not the proper answer for the safe state. The deadlock may occurs, but the system can allocate resource to each other in some order. So in that case, it will be in a safe state. The system can allocate resource in a way that avoids deadlock. It allocates the resource to others. In that way, it avoids the deadlock. So then it will be in a safe state. It does not mean the deadlock does not occur. Okay, for this option B is the right answer. We have seen what is operating system. Let's recall. We have seen what introduction to operating system. We have seen what is CLI and GUI and functions and function of operating system. So remember all this: process management, memory management, file system management, device management, security access control management. Based on this, you'll get a question. Then we are seeing function of types of operating system. These are the types of operating system. Then we have seen OT process management. Then process scheduling algorithm we have seen. We have seen memory management. In that we have seen paging and segmentation. File management. And IO management. Then we have seen deadlock. And we have seen the system, what is system calls. And we have just recalled everything. And we have solved few questions based on this. Yes. All right, everyone. That's bring us the end of the today's session. Thank you all for your active participation and attention to throughout the class. Wishing you all the best in your preparation. Take care and see you in the and see you. Thank you.